Hello, everyone. I hope you all are doing good. So, I'm back again today with a new topic, which is Redshift to perform ETL from DynamoDB to Redshift. Okay. So, nowadays, you must be seeing in the industries that companies are looking for a solution on data warehousing. We can do a setup of data warehousing in the traditional infrastructure also, but companies are looking for the model where they have to manage less and they can focus more on their business capabilities to get more insight into their business. Okay, because we know data is one of the important pillar of any company. Okay, so now before giving you an overview on this, let me introduce myself first. So I am Jatin Goyal and I am an AWS authorized instructor. Regarding the experience and certifications I have, so you can watch it here. So I'm having almost 5 years of experience working as a corporate trainer and I am holding multiple AWS certifications. I'm a cloud practitioner, essential certified, along with I have all three associate level certifications with me. I am an official restart trainer and I am also holding data analytics specialty certification. Okay. If you want to reach out to me, like there is a QR code, you can scan this QR code and you will be redirected to my profile where you can connect to me. So now what's for today? Like I have already given you an overview that what we are going to perform, but what we have to know in that particular context. So I have listed down the agenda. So I'm going to give you an overview of Amazon Redshift, overview of DynamoDB, services which we are going to use in this particular demo, and then we will move towards our demonstration how to perform ETL operation from DynamoDB to Redshift. Okay. So we know that like whenever we design any architecture, database is a tier in our architecture which can help us out to perform transactional as well as analytical operations. Okay. And if we will go deep dive into databases, there are different type of databases solutions available in the market, in the industries. But first thing which comes into our mind, that is the relational databases, where we store the data in form of rows and columns in a tabular format. Okay. So in AWS also, which is one of the popular cloud provider in the market, we have different managed database services available. Soon I'm going to help you out with one link with one official documentation on AWS where you can get the list of different database services according to your use cases. Okay. So if I have to give you a quick overview on Redshift and DynamoDB, so I will say Amazon Redshift is specifically used for data warehousing. If you have to implement a data warehousing solution in the AWS, then Redshift is a choice for you. Okay. So Redshift is a fully managed service, and Redshift also comes into the serverless architecture. We have a concept of Redshift serverless too, but we don't have to go there right now. Okay. So if you are looking to implement a Dynamo, or you can say to implement a data warehousing solution in the AWS, then you should look towards the Redshift, Amazon Redshift, which is giving you more advantage as compared to the traditional infrastructure. And if I have to sum it up in a single liner statement, I can say that advantage in sense of that you will have to focus less on the infrastructure maintenance, or there will be less overhead in terms of managing or provisioning the infrastructure. You can majorly focus upon your business capabilities. Okay. Next thing, if I have to explain DynamoDB in a form of different keywords, I can say DynamoDB is a fully managed, non-relational, serverless, NoSQL database services where you are storing the data in form of key value pairs. Okay. And the use cases of DynamoDB, there are a lot more use cases, but some of the use cases are if you are looking to design some gaming application, some leaderboard, you can use DynamoDB for that. So today, what we are going to see, I'm going to provision two databases, one in DynamoDB and one using Amazon Redshift. And then we will perform the ETL operations where we are going to migrate the data from DynamoDB to Redshift. Okay, that is something extract, transform, and load. So let's get an idea on the number of services or the list of services we are going to use in this particular demonstration. So if you will come to this slide, we are going to use Amazon DynamoDB. Then we will use one of the feature of DynamoDB, which is DynamoDB stream. Okay. This feature is basically used in order to capture any modification events in the DynamoDB, and later we can process those events using different services. AWS Lambda, which will be used here in order to poll for any event changes in DynamoDB and then to process those events. Okay. Kinesis Data Firehose, that will be used for the near real-time streaming. S3, which will be used for the intermediate data storage location. And finally, we have our destination, which is Amazon Redshift, where we are going to migrate our data. Okay. So now if I have to give you an overview on the architecture, how the architecture is. So let's say like I have a table which is existing in a DynamoDB and I am adding the data into the DynamoDB table. I'm adding items into the table. I will enable DynamoDB stream, which will capture the modification events in the DynamoDB. Then I will write a Lambda function, which is going to poll DynamoDB stream in order to process those events. And later it will stream those events to the Kinesis data firehose. From Kinesis data firehose, we are going to perform copy operations to the Redshift with an intermediate location as S3 bucket, simple storage service. Okay, that is an overall intro or the overview of the demonstration which we are going to have as a part of this particular agenda today. So now let me take you very quickly to one of the link I was talking about, and that is something purpose built databases in AWS. So if you will see this list, you can see here we have different types of database services. You can see like they have divided databases into form of relational, key value, in memory, document, white column, graph, and lot more. If you want to get an info about these types, you can simply hover on this and you will get a nice introduction on these databases type. Like for the relational databases, you can say here you are storing data with the predefined schemas and relationships between them. Okay. In terms of use cases, you can see what are the use cases of these different database types and what are the AWS services which can offer you these particular services. Okay. So in case of Redshift, you can say it's a relational database service. DynamoDB, you can say it's a key value. Okay. And if you will see the use cases for DynamoDB specifically, you can see it is designed for high traffic web application, e-commerce system, and gaming applications. And Redshift, as I mentioned you, it is designed for data warehousing solution. Okay. So now let me quickly take you towards a demonstration. We will see it practically. So for that, I have quickly logged into my management console. Okay, this is an account I have where I am going to perform this demonstration. If you don't have an account, you can always create a free tier account in the AWS where you are going to get some quotas, some limits using which you can practice or you can explore AWS services. Okay. So now the best part, like when you are performing any demonstration, you can open multiple tabs, like multiple tabs for multiple services. Okay. So I'm opening multiple tabs as per the list of services I have shown you, which I am going to use in this particular demonstration. So let me open DynamoDB in one tab. Let me open Redshift in one tab. I'm opening Lambda. You can simply type the name of the services in the search bar. And there is Kinesis Data Firehose. Okay. And IAM is already there. Okay, so always follow this practice whenever you have multiple services involved in a demonstration you're going to perform. Open those services in the new tab so that work you are doing for one of the service will not be overwritten by opening another service in the same tab. Okay, that's great. So let's start with creating a Redshift cluster. Okay, why I'm creating a Redshift cluster? Because Redshift cluster usually takes time to come up and running. So let's create a Redshift cluster first, and then we will create another components which we are looking for. Okay, so let me go to Redshift. If you're interested to know more about it, you can obviously get an overview from here too. You can see Redshift accelerate your time to insight with fast, easy, and secure analytics at scale. Means you can perform analysis. You can get some insights into your business. So basically, like data warehousing, if I have to define that, it's a centralized repository where we are containing the structured data, or where we have the structured data stored which is ready for the analysis. Okay, from where we can get the insights into our business. Okay, I had told you we have the Redshift serverless options available. If you want to try Amazon Redshift serverless, you can go ahead. But my goal is to create a Redshift cluster. So I'll simply go here and I will say create cluster. So when you're creating cluster, you have two options available. You can create cluster for your production environment. You can create cluster in a free trial. Okay. So usually, like when we start practicing, when we start exploring the AWS services, it's always recommended that you can use free trial option so that you will not be landed into the situation where you are getting charges from the AWS. Obviously, if you're looking for running a production-based workload, in that case, you should choose a cluster for production. Okay. So just give any name. I'm just giving a name, Redshift cluster demo, for example. I'm obviously using a free trial. So as soon as I'll choose a free trial, I can see that it has automatically taken different configurations for me. In terms of node types, in terms of node sizes, okay, there is a sample data available, and this is a database configuration. Okay, so I'll just keep my admin username as AWS user, and I can provide my password. Okay, for this particular demonstration I will need this username and password, so I'm going to make a record of this. Obviously, like in the real time, you should not change these passwords and username. Like username maybe you can share, but password you should not share. That is a confidential information, but I'll just make a note of it because this is something I am doing for a demo purpose. So you can just see the password, and I'm just going to take a note of username and password. I have a file here where I'm going to keep the Redshift password and username. Okay. And let me quickly click on create cluster. Okay. Let me see if something is wrong. It's saying the parameter master user password is not a valid password. Let me just see the naming conventions. So that's a good thing. You should always troubleshoot on the basis of error you're getting. So you can see that these are the things which you have to keep in your mind. It can be any printable ASCII character except the spatial character. So let me remove the spatial character and let me click on create cluster. So this time you can see I'm not getting that error, and Redshift is creating the cluster. So you have to look for the status. Currently the status is creating. Soon the status will be available. Okay, so once the status will be available, we will be good to use this Redshift cluster. Okay, now one more thing, I have to make a change here. What I want to do, like I have created a cluster. Obviously, if I have to perform some queries, I will have to connect to this cluster. So I'm going to use Query Editor, which is an inbuilt interface in the management console to connect to this Redshift cluster. Okay. So in order to connect to a Redshift cluster, I am going to make it publicly accessible. So for that, let's wait for this cluster to be in an available state, and then we will change one of the network configuration to make it publicly accessible. Okay, just for the demo purpose. What's next? Our Redshift cluster soon will be up and running. Next thing, we will create a DynamoDB table. Okay, so I'll go to DynamoDB. Again, if you want to read about DynamoDB, you can read from here. It's a fast and flexible NoSQL database service for any scale. I'm going to create a table. I am ensuring that all the components I'm creating, those will be in the same region. Let's say if I have created a Redshift cluster in a Mumbai region, I am going to create a DynamoDB table in the Mumbai region too. Okay. So I have to create a table called customer. So I already have some existing tables present in my account, but we don't have to worry about that. I'm going to create a new table. So I'm going to create a table with a customer, and these are the different columns. Now the best part about DynamoDB is, due to its NoSQL nature, the schema is a dynamic, means it's not mandatory that you have to define a structure in the starting itself. Like you can have as many attributes for a particular item when you are going to add an item. So you can define the attributes now, or you can define the attributes later due to the dynamic schema. So I'm only defining a partition key because I need to define a partition key, and that is ID. That is my partition key. Okay. So this is my partition key which I'm going to define. Okay. I'm not providing any sort key here. And Rust all settings are default in terms of read capacity, write capacity, auto scaling. Okay. If you want to customize this setting, obviously you can choose this option, but I'm not choosing this option. I'm just choosing a default setting. But for your knowledge, you can go through it. You can get an idea on different table classes. You can also use this capacity calculator to just help you out what should be your RCU and WCU, read capacity unit or write capacity unit. Okay. Let's go ahead with the default settings for now. And let me click on create table. So soon my table will be up and running. Okay, it's in a creating status. Soon my table will be up and running. In the meantime, the table is getting created. Let's quickly create one S3 bucket, which will be an intermediate location. Okay, let's get S3 bucket. So I will navigate to the S3 management console. This is the S3 dashboard. From here, I'm creating a bucket. I'm giving a name. Let's say demo DynamoDB, ETL, Redshift, and I can append current date. Why I'm pending current date? Because you always have to ensure that S3 bucket namespace is globally unique. So whatever namespace you are giving here, that should be globally unique. So that's why I'm appending current date. Obviously, like when we will be a part of any organization, if there are some standards, there are some naming conventions, we have to follow them. Okay. But for a demo purpose, the major goal is to make it globally unique. Rest all settings I'm keeping default. I'm only ensuring that my region is Asia Pacific Mumbai. Okay. And then quickly click on trade bucket. This bucket I'm going to use as a part of my demo. So if you will recall the list of services which we had to cover, DynamoDB, DynamoDB Stream, Lambda, Kinesis Data Firehose, S3, and Redshift. So S3 bucket is there. Redshift cluster we have created. DynamoDB we have created. DynamoDB table. And now we have other things which we have to create. So we'll do that. Before that, let's quickly check the status of our table. DynamoDB table. It's active. And let's quickly check the status of a Redshift cluster. It is in a modifying state. That's fine. So now if you have to open this table, you can simply click on it and you can see various properties in terms of overview, in terms of indexes, monitors, global tables, backups, export and streams, and additional settings. So I'll go to export and streams because my purpose is to enable DynamoDB stream. So you can see here, capture item level changes in your table and push the changes to a DynamoDB stream. You then can access the change information through the DynamoDB Stream API. Let's quickly enable this. Okay. I'm saying for both new and old images means like for both updates and for both adding new items, I want to enable this DynamoDB stream. So you can see capture item level changes in a table and push the changes to a DynamoDB stream. You then can access the change information through the DynamoDB stream API. Let's enable it. Okay. Now, the best part, like which I want to impart you as an extra knowledge, where this DynamoDB stream can be useful, other than like capturing the event information or capturing the modification information in DynamoDB. There is one feature in the DynamoDB called global tables. Okay, so when we have users who are distributed across globe or in different locations, what we can do in DynamoDB, we can create replica of a table in a region of a choice. So now question comes into our mind. Let's say I have a primary table, which is there in a Mumbai region. Okay. And now I have created some replicas in two more regions, one in a Northern Virginia, one in a Singapore region. If there is any changes in the replica, one of the replica, how that change is going to be reflected into the other replicas. So that will be done with the help of DynamoDB stream because it is capturing the modification event and using that information, the tables or the replicas will be updated. Great. So we have enabled the DynamoDB stream. Now I have to add a trigger. Trigger means like when there will be the event changes in the DynamoDB stream. What will be my trigger? So here my trigger will be Lambda. Means Lambda is going to poll the DynamoDB stream in order to process the events. Okay. So for that I should have a Lambda function. So I'll go to Lambda. I'll create a function in Lambda. Let's click on create function. And I'm saying demo ETL DynamoDB Redshift, and again you can append today's date if you want to make it unique. Okay. In the runtime, you have different runtimes available. I'm choosing Python. I have to provide permission. What Lambda is going to do? Lambda has to poll the events from DynamoDB. Lambda has to write the stream into Kinesis data firehose. And also, Lambda has to put the logs into CloudWatch, which is the basic execution permissions in the Lambda. Okay. So one thing is you can customize the policies. Like you can create a role in the IAM and you can create the custom policies based on your need. For a demo purpose, what I can do, I can go to the IAM console and let me create one role. So let me click on create role. I'm creating a role for Lambda. So I'll choose the trusted entity type as AWS service. My use case will be there for Lambda. Let's choose that. Go to next. So now from here, either you can just use a manage policy. That is one thing. You can create a custom policy and you can attach to IAM role, or otherwise you can provide the administrator access if you want. So let's say if you have to provide the access for Kinesis, okay, you can just check the policies which are available for Kinesis. Let's say Kinesis full access, okay, or Kinesis firehose access if specifically it is there. You can see Amazon Kinesis firehose full access, okay, that you can provide. You can also provide DynamoDB access, okay. Let's do that. Let's provide Kinesis firehose access. Let's provide access for DynamoDB. So for that, I'll type DynamoDB and I'm providing access for CloudWatch logs. I told you, if you want to customize your policy based on your need, you can either create an inline policy specific to an IAM role, or you can also create a custom policy and you can attach that to this IAM role. Okay. For my requirement, for my demonstration, I had to interact with DynamoDB, Kinesis Data Firehose, and CloudWatch logs using Lambda. So I'm providing these three access to this particular role. Okay. I'll just go to next. I can provide a role name, again, demo ETL role. And to make it unique, I can append today's date. Okay. I'm keeping rest all information same in terms of description, in terms of trusted entities, and I'm creating a role. Now, this role I'm going to use as a part of my Lambda function. Okay. You can obviously sort it on the basis of creation time. This is a role you have created. Let's copy this. Go to your Lambda. You can obviously say use an existing role. And let's search for this role. Soon this role will be reflected. So this is a role I have chosen. And I'm saying create function. So my function is created. Okay. There's a sample code. Obviously, I'm going to update the code in my Lambda function with the code I have with me. Okay. Before that, I have to add a trigger. So how can I add a trigger? I can add a trigger using this DynamoDB. So let's click on create trigger. Let's choose a function. So this is a name of a function. Let me choose it here. Let me provide it here. And this is a batch size, the number of records Lambda read at once before invoking the function. So for example, let me provide batch size as 10. Okay. Enable trigger, specify whether the trigger should be enabled when you create it, or you can disable it later from the Lambda console. So I'm enabling it. Click on create trigger. As soon as you will do that, you can see an entry here. And if you will come back to the Lambda, if you will refresh this dashboard, you can also see the trigger in the Lambda console, which is here. You can see a trigger. You can always see the information about trigger in the configuration section. You can see this is an information. My trigger is enabled. And the best part is also permissions. So if you scroll down, if you will refresh this, you can see that we have this permissions. Okay, you can see the role document if you want. Like these are based on the policies you have attached. Okay, so now like when the permission point comes for the lambda, you can have an execution role, you can have the invocation permission, but here lambda is going to poll the DynamoDB stream in order to see if we have any event in the DynamoDB. Okay, so for that lambda is already have the permissions defined as a part of the execution rule. Okay, let's go back to our Redshift and let's see the status. It's available. That's really great. Let's open this cluster, or you can simply select it, go to actions and click on add. Okay, now what I have to do, I have to make it publicly accessible. So under network and security, I can see I have this setting, turn on the publicly accessible. Okay, so this is looking disabled to me. That's fine. I can show you how to edit it. Just simply open your cluster, and here if you scroll down under maintenance, you can see all these details. So these are different sections basically you can explore, like cluster performance, where you can see various metrics. You can also have a query monitoring schedules. I'll go to properties. Okay, for my part, under properties I will add it this network and security settings specifically. This time you can see I have this option enabled. So for changing this option, what I did, I clicked on my cluster which was launched. Okay, and I changed the network setting under properties. Okay, so my cluster is getting modified again. I have made it publicly accessible for the demonstration purpose. Okay, so let's wait for our Redshift cluster to be available after these changes, because the next part which I'm going to do, I am going to create an empty table in my Redshift cluster. Okay, so I have created one table customer in my DynamoDB. So I will create one table customer in the Redshift, but that will be empty. I'll show you. Okay, and later what we are going to do, we are going to migrate the data from the DynamoDB table to the Redshift using this particular demonstration. Let's quickly check. It's available. Great. So now if I have to connect to this cluster, I can use this inbuilt interface query editor. Let's wait for this to be loaded. Okay, these are some existing commands. Let me clean that. This is my cluster, which is there. I can see I can expand this cluster. Okay, this is my database name. This is a default schema. And these are some existing tables. Now I am going to create a table. This is a table I'm going to create. Let me create it. I can simply take a query. This is a SQL query, create table customer, and these are the attributes. Let's run that. Okay, it got executed successfully. I didn't get any error. If you want to verify that, you can simply either execute a select query. Let's say select star from customer. And you can execute this query. And you are not getting any result because there is no rows added to this particular table, because my goal is to add the rows or move the data from DynamoDB to Redshift. Okay, now last part, we have our DynamoDB table ready. We have created a stream, we have added a trigger, we have our lambda function ready. Obviously we have to add it a code in our lambda function. Okay, so this is a code I have which I'm going to use. This is a code I have. Let me copy that and let me paste it here. At a very high level, let me just give you an idea what this code is doing. So you can see I'm creating a client for Firehose. Okay, so I'm using a Boto3 library because this is my Python code. Okay, this is a delivery stream name. This is a variable I have defined, and this is a function which I have defined here, convert to Firehose record. Okay, this is my entry point lambda handler. This information is defined in the handler info. You can see lambda handler means whenever my lambda will be invoked, this should be the entry point for the execution of this function. Okay, Inside this, I'm just executing a for loop on the records, which I am getting as a part of the event, which is an input parameter. Okay. And then I'm passing those database record to this particular function, this custom function, which I have created. From this custom function, I am adding the data to the Kinesis data stream, Kinesis Firehose delivery stream, okay, which is used for the near real-time streaming. So I'll go to Kinesis. This is my Kinesis dashboard. If you want to read about it, you can obviously go to a dashboard section and you can see. I'm going to create a Kinesis data Firehose. I'm going to create a delivery stream, okay. Let's click on create delivery stream. What is my source? I have to choose that, and what will be my destination? Okay, my source will be direct put. I'm going to perform direct put operations. You can read the info from here. So you must specify a source of incoming data for your Kinesis data Firehose delivery stream. You can choose one of the following options: direct put or other sources. Choose this option to create a Kinesis data Firehose delivery stream that producer application write to directly. So here I'm going to write the records to my Kinesis data Firehose delivery stream using Lambda. And my destination will be obviously Amazon Redshift. Let me choose that. Okay. So now I will need this delivery stream name as a part of my Lambda function. So I will take that. I'll go back. I can provide this delivery stream name here. Okay. And let me deploy the changes. So my changes are deployed. My Lambda function is ready. Okay. One more thing you can do, you can go to configurations just for a safer side. Under general configuration, you can edit the setting for the timeout. So let me make it 5 minutes, for example. Okay. So this is the maximum time for the execution of a function. So by default, it is 3 seconds and the maximum value can be 15 minutes. So I am making it to 5 minutes. Let me save the changes. Okay. And now let's talk about this delivery stream, which I am going to create. And once this delivery stream will be created, I will have all the components which will be ready as a part of my demonstration. Okay. So I'm not going to perform any transformation. So that's why I am not enabling this data transformation. I'm not going to perform any data transformation using the AWS Lambda. My goal is to add the data or write the records to this delivery stream. And from this delivery stream, I'm going to issue a copy command to the Redshift. Okay. Scroll down. In my destination setting, I have to ensure one thing: ensure that your Redshift cluster is publicly accessible. So that was one of the requirement why I had to make my Redshift cluster publicly accessible, and allows inbound access from the Kinesis data Firehose IP address. So basically, I have to allow this particular set of IP addresses as a part of my Redshift cluster security group. So in my Redshift cluster right now, I'm using a default security group. In a default security group, I'm allowing the traffic from anywhere, but you can customize it. Okay. Let me choose a cluster. So my cluster is this one. I have to provide a username, the one which I had taken here. So this is a username I'm providing. Okay. I have to provide a password. This is a password. I'm providing the password here. Okay. I have to provide a database name. So in case of my Redshift, if I'll go here, my database name is Steph. This is my schema. So I'm providing a database name as Steph. Okay, I have to provide a table name. I'll go back again. And if you will see, if you'll refresh this, you can quickly expand it. Under this public schema, you have the tables, and the table is customer. This is a table where I want to copy the data. Okay, so let's quickly provide this table name. So I'll go back, I'll provide a table name. I have done. Okay. I'm not providing any columns, which is an optional section. So you can specify a comma separated list of column names to load the source data field into specific target column. The order of the column must match the order of the source data. So that is optional setting. There is no need to provide that as a part of a copy command. Usually, like when we issue the copy command, in order to copy the data to our Redshift cluster, we can pass different parameters. Okay. And usually, if you have to pass the column name that you pass, like when the order is different. So right now, I'm not passing any column name. I'm choosing the intermediate S3 location. So my intermediate S3 location will be the bucket which I have created. Let's open this bucket. Let's take this name and let's come back here. Okay, let me just provide this, or you can directly go to browse. You can just browse for the bucket. You can also get it from here and you can choose it. Okay, I'm not providing any intermediate S3 prefix, and this is my copy command, like copy customer from S3 demo DynamoDB ETL Redshift with today's state slash manifest. Okay, so basically, when the data will be written to the Kinesis data file host delivery stream, it will write the data to the intermediate S3 location from where the copy command will be issued. Okay, I'm just providing CSV here that you have to provide and show that. I scroll down and I'm creating a delivery stream. Okay, this delivery stream will be created soon. So means now my all the components are ready. I have a DynamoDB table, I have Kinesis Firehose delivery stream, I have a Lambda function, I have S3 bucket, I have Redshift cluster, and I have also used the IAM role. Okay. Now the last part will be, let's start testing this. So before that, let's wait it for this delivery stream to be ready. The status is creating. Maybe we'll have to wait for a minute or two, and then this delivery stream will be ready, and we will test our use case. Okay, we'll again wait for a minute or two, and basically for any errors, like once the data will be written to our Kinesis data file host delivery stream, we can see any errors in the destination error logs. This is the log row. Okay, so for that, we'll have to wait. It's active. What's the last part? The last part is, let's start adding some items in a DynamoDB table, because as soon as we'll add the items, okay, what will happen? There will be an event which will be captured into DynamoDB stream. It will trigger my Lambda. Lambda will read the records, process the records. It will write it to the Kinesis Firehose delivery stream, from where the data will be resided into the intermediate S3 location and the copy command will be issued. Okay, so you can simply click on create item. So either you can just add the attribute name, or either you can add the attributes in the form of JSON. So I have the syntax available. So this is my attribute which I'm going to add. Let me just do one thing. Okay, I have created an item. Let me create few more items. Before that, let me just do something. Let me just check my DynamoDB items and also the code here. Okay, so here I'll just make one change. I'll change it to ID. And now we will again go back and let's quickly create more items. So I'm creating more item. The only thing you have to keep in your mind, that is your ID should be unique. Okay, so let me change the ID, because this is a partition key to 2. You can change this name, any name you can change. Let's say Rocky, or city you can keep as it is. You can change the designation if you want, and you can also change the phone number. Okay. Let me take this. Let me create one more entry. So again, I'll just click on create item. I'll just add a view here. Or maybe you can say run and quickly click on create item. Okay, the item got created. Now what will happen? I have three items in my DynamoDB. Okay, in the first item, I had just passed the ID. Okay, with this caps. So the changes I have made. But let's quickly check the Lambda dashboard. This is my Lambda dashboard, and let's quickly monitor the logs in CloudWatch. So I'll go to CloudWatch. I will simply say view CloudWatch logs. So for that, I clicked on monitor section in the Lambda, and from there, I navigated to CloudWatch logs. Let's quickly come back here, and we will check the log streams. So I'll go here, and I'll see this one. Okay, you can see. You can expand it if you want, just to check if there is any error. So these are the records. Okay, if you'll expand this TDB record, this is a record I had added. And you can see there's a firehouse record. This is a firehouse record. Okay, means we have written the data to the Kinesis data firehouse. And you can also see this thing. Okay, so basically you can explore the logs in CloudWatch in order to understand is everything looking fine. Okay, you can see these entries. Okay, so these are the logs which has been added into the CloudWatch in order to check if our function is getting executed successfully or not. Okay, so you can see that. You can see this is a record ID. This is my HTTP header. Okay, and everything you can see from here. And my HTTP status code is 200. So 200 means everything okay. Now let's quickly go back to your Kinesis data firehouse. And here you can see, is there any destination error logs? Because soon it's going to add the data to an intermediate S3 location. And from there, my data will be copied to Redshift. Okay, so we can see these metrics. Is there any incoming bytes? Let's wait for a minute or two. And we can also see delivery to Amazon S3. So for that, let's quickly open our S3 bucket, which we had created. This is our S3 bucket. So we'll have to wait for a couple of minutes. In the meantime, let's quickly go through these particular block where you can see different database services. Okay. So now the best part is that if you're interested, you can also see learn more with 10-minute step-by-step tutorials. So if you open this part, you can see getting started tutorial. So these are the tutorials for different databases. Create your first Amazon RDS database, create your first Amazon Aurora database, create your first Amazon DynamoDB tables, and other tutorials you have. Okay. And you can also go to this repository just for extra knowledge. These are the hands-on repositories. Okay. So these hands-on repositories can give you a very good idea. Let's say if you have to create and query a NoSQL table, you can simply click on this and you will get step-by-step instructions. These are the step-by-step instructions you can see. That's a very good blog, you can say, in order to perform different tutorials. And the best part is that you can explore different categories too. Let's say if you have to create and connect to a Microsoft SQL Server database, again, you have step-by-step tutorials here. And the levels has also been given what you have to do. So that's a great exercise to try with. Okay. So the link you can get it from here. If we'll go to purpose-built databases, okay, the one which I had opened. If we'll go to this particular page, which is giving you the list of purpose built databases in AWS with their use cases and listing down different services which comes under those use cases. You can get an idea on all these things. Okay, let's check the status. Let's quickly refresh this. I can see there are some incoming bytes. Okay, earlier it was empty. Now I can see some incoming bytes here. These are some incoming put records. These are some incoming records. Let's quickly check the status of a S3 bucket. I can see a folder got created. So this is my manifest folder. Inside this manifest folder, I can see we have the partitions created. And this is the put record. Okay, so for testing that, let's quickly try to execute a query. And can you see the result here? So these are the results which are here into my Redshift table. So what I had done, like I had created a DynamoDB table and now I had migrated the records from my DynamoDB table to the Redshift. Okay, so that was the demonstration I wanted to showcase in front of you. And I am going to come back with more such demos in order to help you out with more ETL operations or how to copy the data into Redshift table. Okay, so that's what for today. I wanted to help you out. Thanks a lot for being a part of this particular overview. Stay safe, stay well, take care, all the best, and we are going to meet soon for more such demonstrations, for more such discussion. Thank you very much. Bye bye, and take care, everyone.